We're going to continue our math adventure. Today we're going to be using proportions to solve for an unknown length of a side on a similar figure. Now, if we go back and we think about what a similar figure is, it simply means that corresponding angles, meaning angles in the same position, have to be identical angle measurements, but corresponding side lengths have to be proportional. And because of that proportional part, we can set up proportions and use cross products in order to solve. So the way that we do that is, first we have to think, how are we going to set up our proportion? And so I always think of labeling the figures as small or large. And usually for me, I always like to put the small number on top of my ratio and the large number on bottom of my ratio. So my next step is I have to find corresponding side lengths, because those are the things that are proportional, not the angles. So corresponding means in the exact same position. So when I take a look at 16 and 24, they're in the same position on their figures. And so I'm going to put the small on top, and I'm going to put the large measurement on bottom. That's the first part of my proportion. I've got one of those ratios. Now the second part of the proportion has to be the side length that I'm missing. So I know that I don't know what X is. I don't know that side length, but I know I'm going to use this proportion to figure out what that side length is. So I have to find the corresponding side length on the other figure. Well, when I look at that corresponding side length, X and 18 are sitting in the same positions on their figures. So I'm going to put X on top and I'm going to put 18 on bottom. Now here's my proportion. And we know we can use cross products in order to solve proportions. So I'm going to take those numbers that are on the diagonal, and it's cross products, so we have to use multiplication. So I'm going to do 24 is to X, or 24 times X, and I'm going to do 16 times 18. Well, 24x is just 24x, and 16 times 18 is 288. Now this is only a one-step equation, so we need to get x by itself, but it has this times 24, so I'm going to use inverse operations and I'm going to divide by 24, but whatever I do on one side, I have to do on the other. When I solve that, I see x equals 12, which means this unknown side length has to be 12 units. That's the best way that you can use proportions to find missing lengths of similar figures. Now sometimes the figures don't seem similar. So say we have a tree and a person, and we say, all right, I don't know the height of the tree, but the tree casts a shadow that's 10 feet long. But I do know that this woman is 5 feet tall and casts a shadow that's 4 feet. Okay, the tree and the woman don't seem like they have anything in common, but they're actually similar figures. Because when I take a look and I create the figure that matches, it's actually a triangle. Two different sized triangles, but they're still triangles. Which means I know the angle measurements have to be the same, but my side lengths are different. So when I go to set up my proportion, I'm going to take two side lengths that I know, and again, I'm going to keep the smaller figure on top, the larger on bottom, and I'm going to say 4 is to 10, as 5 is, and I'm just going to say that's x, as 5 is to x. So again, let's use cross products. So I get 10 times 5 equals 4 times x. So I get 50 equals 4x. Now it's okay to have decimals. Lots of kids think that if you get a problem like this, you can't work it. Remember, decimals are just our numbers. So we're still going to divide both sides by 4 to get that variable by itself. And when I actually divide it, I get 12 and 5/10, which means the height of the tree has to be 12 and 5/10 feet. So don't think because the objects seem not very similar that they can't be calculated using the concept of similarity, because they can. Now sometimes your figures are not going to be drawn going the same direction, and so there's a code within the description of the figures that we can use. So notice they said that figure ABCD is similar to figure JKLM, but I'm looking at them and they're going in different directions. Well, the way that I can redraw this where I know it's accurate is A's in the first position and J's in the first position, so they have to be drawn in the same way. So what I do is I just draw another figure, and I don't even think about changing or calculating it. So I'm just going to put J in that same position as A. And B's in the same position as K, so I see B there, so K's got to be there. C's in the same position as L, so I have to have L there, and D's in the same position as M. So you don't have to worry about flipping it, just read the code that you see there. Then I can add in my measurements. So I know that J to M is 6 feet. I know J to K is 12 feet. I know M to L is 12 feet. And L to K is 3 feet. Then once I have that set, then I could solve for my unknown. So this is frequently how you're going to see these problems. Always remember to just read the key, redraw your figures, and then you can go back to solving their proportions. So this is one of my favorite things to do with proportions. I hope you enjoy it. I hope you're up for the challenge.